Yeah, if you are able to get this done with these two chapters, it will immensely help you going ahead with the other chapters. Okay. Right. So the minute we discuss, we come across mole concept. The first thing we must know is that how the term mole is related to us whenever we talk about elements or molecules. Okay. So for instance, when I use the word mole, I'm sure everybody is aware that mole is just a number. Just a minute, I'm getting a call from the office. Right. When we discuss about the mole, the first thing that comes to our mind is it's a number, and the value of that number is 6.023 into 10 raised to 23. And every value of a number may also be given as a name. For example, 12 is a value, and the name which we give that 12 is dozen, right? Similarly, this is a value, and the name which we give here is Avogadro's number. Avogadro's number. Okay. So this is a basic information I want all of you to have about mole. So mole is a value, it's a number, it has some value, and the name of that particular number is Avogadro's number. Got it? Now, when we convert atomic masses or mass numbers into the gram units, then they can be denoted in moles. For instance, if we take simple elements, like hydrogen, carbon, nitrogen, oxygen, sodium, potassium, calcium, sulfur, chlorine. These are most commonly used elements. One second. Pasca. Please press. You have approved. Yeah. So H, C, N, these are all various elements which we'll be using, and atomic numbers for these elements, atomic numbers A is 1, 6, 1, 12, 14, correct? Atomic mass here, my mistake, is atomic mass. So 14, 16, 23, 39, 40, 32, got it? Chlorine has two types of atomic masses. We average that, and that will come to be 35.5. Okay, so that will be 35.5. So these are atomic masses, students. Clear? Now, once you know atomic masses, if atomic mass is nothing but we also term them as mass number, if you recall. So mass number or atomic mass is actually number of protons plus number of neutrons. So these are the number of protons and neutrons what we have. Now, taking this into consideration, if we convert them into gram form, so hydrogen will become 1 gram, carbon 12 grams, 14 grams, 16 grams, 23 grams. If we write everything in grams, this will convert into this will convert into mole terms, which means if I take one second, so if I take like 1 mole of hydrogen atoms, it implies it is 1 gram of hydrogen atoms. Clear? Which implies we have 6.023 into 10 raised to power of 23 hydrogen atoms. So I hope all of you got an idea. 1 mole represents that 1 gram of hydrogen atom, and that is equivalent to these many number of hydrogen atoms. Clear? I would want all of you to write the same way for all these elements. For example, 12, if you see 1 mole of carbon atom is equivalent to 12 grams of carbon atoms, which is equal to 6.23 into 10 raised to power of 23 carbon atoms. In a similar way, please write it for everything. Just I'll be back in 2 seconds, students. Write the same way for everything. Right. So I think all of you know how to write this everything in moles, correct? The minute we know how to write them in moles, now you should be able to find the next thing, that is formula based on moles. So now for any number of moles, we write what is the given weight or the weight or mass given for an element, and that divided by atomic mass. Atomic mass, if it is a molecule, it will become molecular mass. Correct? So that is the next thing you should be ready to practice. For example, if I told you 20 grams of NaOH, okay, 20 grams of NaOH and 49 grams of H2SO4, 49 grams of H2SO4, 400 grams of calcium carbonate, and 4.5 grams of H2O. If these are the simple examples I take, you should be able to immediately respond these weight information into number of moles information. So how do we see that? For instance, number of moles will be equal to weight given divided by molar mass. Now for NaOH, what is the molar mass? Sodium is 23, atomic mass, atomic number or mass number is 23. Hydrogen is 1, 24. Oxygen is 16. So 24 plus 16, 40. So 20 by 40, which makes it 0.5 moles. So now you're responding the weight information in moles. This response is also expected from you quickly. Okay. So do the same thing for other students. Jaldi jaldi karo. Find molar mass. Find molar mass and then respond to the weights now. Okay. Everybody respond that in moles now. Now you can see number of moles will be equal to 49 divided by 98 if you have got that. Got it? Same way, N is equal to 400 is the given weight. By the molar mass, if you do that, you will get this as 200. So 2 moles. Number of moles 4.9 divided 4.5 divided by 18. 18 is the molar mass of water. So which makes it so 4.5 what we have, if you multiply that with 2 on both the ends, so we will get this as 9 by 18 into 2. So it goes 2 times, so 1 by 4. So 0.25 moles. The second response, first response is to represent everything in hydrogen, everything in terms of moles and atoms. Second thing, you have to respond everything in terms of number of moles from the given weights. So I think all of you
400 gram of CSU3, it will be 4 moles.
Where beta 4 moles, sorry. Step 4 moles. So 100 and we get 4 moles. Right. Done. This is the second response expected from you students. Got it. Now we know I'm expecting that you guys are comfortable. H2SO4, H2SO4 molar mass is 98. Shraddha, check out how much you have. 2 plus sulfur is 32 plus 4 times of 16. That is 98. Okay. Right. Next thing what we need to respond. Next thing what we need to respond is how to relate moles with electrons, how to relate moles with protons, ions, charges, correct? Valence electrons. This is a definite question in KVPY. So you just be given a simple information and you're supposed to respond them in terms of moles or respond them in terms of number of electrons, number of protons, number of ions, the total charge, anything that is related. So now I'm doing that third response where suppose if at all I have been given to find the number of valence electrons, the number of valence electrons in 98 grams of H2SO4. This is given. So you can see that what I will do, first I'll calculate the number of moles of molecules. 98 by 98, I'll get 1 mole of H2SO4. This is the first thing we will do. Any question that is given, the minute we get a data, first we'll convert that into moles. So we got number of moles. Then I will relate the moles with the atoms. Like 1 mole of H2SO4 will have 2 moles of hydrogen plus 1 mole of sulfur plus 4 moles of oxygen atoms, sulfur atoms, hydrogen atoms. This is how it would be present, which means if I say 2 moles of hydrogen, 2 moles of hydrogen, we know 1 mole relates how many electrons it has. One hydrogen will have only 1 valence electron. So we have 1 valence electron from here. 1 sulfur will have, 6 valence electrons. 1 oxygen will have 6 valence electrons. Okay. Now, if 1 hydrogen atom is taken, we'll have 1 valence electron. If I take 2 moles of hydrogen atom, I will have 1 mole of hydrogen atom. So since it is 2 moles, now I'll be multiplying that with 2 and write this as moles. Same way here it is 1 moles and here it is 4 and moles. So now you look at it, it is 2 plus 6 plus 24. Got it? So we have 32 moles of valence electrons. 32 moles of valence electrons. So from here I can say number of electrons, so number of valence electrons in 98 grams of H2SO4 will supposedly be 32 times of 6.023 into 10 raised to the power of 23 electrons. These many electrons we will have, or we can simply write it as 32 Na. Na means Avogadro's number. So is this question clear to everyone? Right? So how to respond in terms of moles? So if the question is asked more in valence electrons, this is how you would respond. So I hope all of you followed that. Now, given a question, I will give you a question now. Please try to convert that into electron data. Got it? And see how much you are getting there, right? So first I'll give you that, then I'll go to the next example. Find number of valence electrons in 120 grams of carbonate ion. Do that. See the above question. Try to follow the same way and write it down. Just so that you can note also, and now you can solve also. Okay. Note that and solve it, everybody. Post me your answers, students. Come on, faster. Aryan, are you able to relate the concepts better? Aryan, Arya, how about you?
Sir, can you zoom out the question?
46 Na. One answer I got. See if others have got the same thing. I told you first find the molecular weight. Molecular weight of CO3 2 minus
Sir,
will be how much? So it is 12 plus 48. Okay. So we are getting this as 60. So molecular weight of carbonate is 60. So number of moles of carbonate will be weight given divided by this. So which means 2 moles. So total number of moles of carbonate given is 2 moles. And out of which, how many valence electrons I have? See, valence electrons in carbonate will be, carbon has carbon has 4 valence electrons plus 3 times of oxygen has 6 valence electrons. So 18 plus 22, 18 plus 4, 22. And there are 2 minus. Remember students, when you have 2 minus means there are 2 extra electrons, and extra electrons will always be in the valence shell. They will be always in the outermost orbit. So therefore we have totally now 18 plus 2, 20 plus 4, 24. So 24 valence electrons per molecule or per ion. So we will have 24 valence electrons per ion. And how many ions I have now? I have 2 moles of ions. Hence, total valence electrons will be equal to 2 times of 24. So which is 48 moles of valence electrons. Moles of valence electrons. Or we can write the answer as 48 Na. Okay, beta. Right. So we have to multiply that 2 also. Correct. Shraddha, I think possibly you have not taken that electrons into consideration. Yeah. You have to take that electrons also. Dear students. Now, if negative charge is there, you are adding electrons. If it was positive charge, then you will remove electrons. That's all. Clear? So on a similar terms, if I asked you, find the number of valence electrons in 9 grams of, sorry, yeah, 9 grams of ammonium ion, NH4 ion. Now do this. Everybody do that. First, find the molecular mass, everyone. Molecular weight of NH4 plus. Nitrogen is 14 and there are 4 hydrogens, which makes it 18. which means number of moles will be equal to given weight by 18. Yeah. Yeah. Finish that from here. I give you enough hint, so you should be able to figure out. Total valence electrons 18 Na. Others? Somebody got 8 Na, 4 Na. What is 4 beta? Soham, it is 4 Na. Yeah. Okay. Look at this. So we have here as 0.5 moles. 0.5 moles. Now, first we need to figure out how many valence electrons NH4 plus will have. Nitrogen will have 5 valence electrons. Hydrogens will have 4 valence electrons, but the plus represents I need to remove one. So therefore, there are 8 valence electrons per ion. So per ion, we have 8 valence electrons. Hence, total valence electrons will be 8 into 0.5 moles of valence electrons. So which is 4 Na electrons, valence electrons. So I hope all of you got that. Why 20, Anu?
सर आप क्लियर हो गया वो
Okay.
खत्म हो गया था
ठीक है. Right, Shraddha, I hope you understood that. Right. So I think you guys are comfortable in dealing this question. So ये आप ऐसे टिक मार्क कर लो कि KVPY में हमारे साथ एक क्वेश्चन हो जाएगा. Okay. In stoichiometry, you'll be able to easily get this question. Second, now comes a question based on combustion. Okay.
सर एक मिनट नोट करते हैं
क्या बेटा?
नोट नहीं किया
नोट करने का क्या? आपने इतनी देर सॉल्व नहीं किया क्या? साथ में सॉल्व करो बेटा, टाइम वेस्ट हो जाएगा फिर. Arya, where did I take -1, dear? Acha, this one. This -1 implies the plus charge here. The plus implies that I have lost one electron. That means NH4 as a system has lost one electron. So valence electron में से एक electron कम है total valence electrons. Arya, is that clear now? Wherever you have plus, you subtract those many charges. If it is minus, you add those many charges. Minus represents those many electrons we have. Okay?
Yes, sir.
Yeah. Now look at this. To learn the combustion questions, this is also every year. If you see last 10 years, every year there is one question on combustion. For that, we need to understand how to relate volume with number of moles. Volume with number of moles. Okay. So it's simple that if you have a gas being occupied in a certain volume, okay, and imagine if this gas is 1 mole. So 1 mole of a gas, the pressure maintained here is 1 bar. The temperature is 273 kelvins or 0 degrees Celsius. Okay. then the total volume occupied by this gas would be approximately 22.7 liters. And if the pressure is 1 atm, okay, so if pressure is 1 atm and rest of them are same, then the volume occupied will be 22.4 liters. Most of the time we will be using this data because pressure हमेशा ATM में दिया रहेगा. अगर आपको specifically वहां पे mentioned है that it is at pressure of 1 bar, then you will take volume as 22.7 liters. Otherwise, we'll take volume as 22.4 liters. So remember, students, both of them are termed as STP or NTP conditions. STP or NTP conditions. And whether you write this one or this one, both of them are STP or NTP conditions. Okay. Most accepted is this one. 22.7 liters is most accepted, but a lot of questions come across the data where you will take 1 atm. So we can use the volume as 22.4 liters. अब देखो मैं कैसे relate कर रहा हूँ. Suppose if you had like 48 grams of 48 grams of O2 gas at STP. The minute I use the term at STP, what does this mean? That number of moles of O2, first I will calculate as 48 by molar mass of oxygen is 32. Okay. So this is 12 by 8, or this would simply be 3 by 2, which means 1.5 moles. So I have 1.5 moles of O2. I have 1.5 moles of O2. We got the number of moles, and we know that 1 mole of gas shall occupy 22.4 liters. So 1.5 moles of gas, of O2 gas, will occupy how much volume? So which is 22.4 into 3 by 2 or 1 by, we can write it as 1.5. So it is how much? This is 22.4 liters and 11.2 liters, half of that. So 6 and 3 and 3. So 33.6 liters is what we will have. Clear, students? So converting the weight into moles, and from moles we are converting into a volume data. I think all of you are comfortable with that, correct? So learn to write in volume data, or reverse. Volume is given, you need to convert that into mole data or gram data. Okay. Now learning this, how this will be useful for combustion reactions. Combustion reactions. See, if you are reacting any species with sufficient oxygen, okay, burning any compound in sufficient oxygen.
Sir.
1 minute, beta. Sufficient oxygen is combustion. Yeah, tell me now.
Sir, in the last sum we have to use 22.7, no? STP where said.
What did I say? STP or NTP, both can be used depending upon what pressure is being used. Okay? I'm just assuming pressure is 1 atm, so it is 22.4 liters. Okay?
Yes.
Be very specific with the question. If the question is given 1 atm, then you will use 22.4 liters. Okay? Right. Now, burn. Yeah. Now look. For example, if I take carbon and burn in oxygen, it will become carbon dioxide. If you have hydrogen gas burning in oxygen, it will become H2O. Okay. If you have hydrocarbon, CXHY, I'll take simple examples first, like CH4 plus O2. Then that will become a mixture of these two, carbon dioxide and water. Okay. So here, if you balance this, we will have to balance first the carbons and next the hydrogens. There are 4 hydrogens, so 2 here. Next, balance oxygens. O2 and O2, total 4 of them. So 2 should be here. So this is the balanced equation. Same way, if you have something like C2H8, C3H8, C3H8 plus O2 is giving CO2 plus H2O. Again, we should be learning balancing the equations. So we have 3 carbons here. Make sure we have 3 carbons on the right hand side. We have 8 hydrogens here, so we need to have 8 hydrogens here as well. So which means 4. Oxygens, 3 2s are 6, 6 plus 4, 10, which means I should have 5 here. Clear? So I think all of you know how to balance the equation for simple hydrocarbons, correct? So if we write any general equation, CXHY, then this will be X plus Y by 4, X plus Y by 4 of O2 is giving X moles of carbon dioxide plus Y by 2 moles of H2. So this is the combustion reaction generally. Okay. Now the question asked would be, if we take certain amount of gas, okay, some weight of the gas, how much oxygen is needed, or how much oxygen at STP is needed? This is a typical question that will be asked. Now I'll frame a question and I would want you to try to answer that. Okay. 64 grams of methane is burnt in O2. Find the volume of O2 used and volume of carbon dioxide formed at STP. Sure, do that everybody. Very, very simple question. So I'm expecting all of you should be able to do that. Write the overall equation. I've given you what is a combustion reaction, correct? Use that combustion reaction and try to figure out how much is the volume of O2 and how much is the volume of carbon dioxide at STP. Faster, students. Give me an answer fast, students. Come on.
So we are talking about
You stuck somewhere, beta? Siddhi, this is for oxygen, dear. Siddhi, the answer you posted is for oxygen. Okay, do the same thing for carbon dioxide.
sir, please scroll above.
Look at this. CH4 plus O2 is giving CO2 plus 2H2O. So here we shall have 2. So this is the balanced equation. Now students, first we have been given the weight of the methane. So I can calculate number of moles of methane as 64 divided by 16 because atomic number of methane is 16. Atomic mass of methane is 16. So number of moles I got it as 4. So I will write it here as given. Given is 4 moles. Now relate this. Dekho, 1 mole of methane requires 2 moles of oxygen. So 4 moles require how many oxygens? Everybody?
8.
8 moles. So therefore we require 8 moles, and 1 mole of methane is forming 1 mole of carbon dioxide. So 4 moles will form how many moles?
4.
4 moles. So 4 moles. So now we need to find the volume of O2 will be equal to 22.4 liters into 8, or volume of carbon dioxide will be 22.4 into 4. That's it. This is what you need to do. Now check your answers. Siddhi, I hope you understood, beta. So I want all of you to finish that, write the values, how much you are getting, and do the next question. If चलो आया सबको, last one. Nobody is responding. Come on, students, say yes, no, or write something. Shreya, Soham, Vaishnavi, Priya, have you all finished? At least give me a sign if you are done with the last question.
Pressure of oxygen is 179.2.
179.
9.2.
What about here? Carbon dioxide is 89.6.
Sir, 89.6.
Right. Those who are finished will try the next question. देखो बेटा, very important exam tip is you cannot spend more than 3 minutes on a question. 3 minutes से अगर ज्यादा जा रहा है, unless you are at the last answering part, अगर 3 minutes के अंदर क्वेश्चन समझ में आया और आपने वहां पर सॉल्व कर पाए तो ही वो क्वेश्चन आपसे हो पाएगा, नहीं होगा तो आपको सीधा सीधा नेक्स्ट क्वेश्चन पे जाना चाहिए. In this case, while we are solving, within 3 minutes, if you are not arriving close to the answer, you immediately talk to me. You tell me where is the problem coming. Okay? But do not waste time just thinking. Okay? I hope all of you understood. This is a very, very, very important tip for exams. You have to be very clear, like what you are doing. If you're not able to do that, quickly respond to me, ask me, I will help you solve it. What happens the minute we start thinking, right? हमको इतने ज़्यादा multiple thoughts आ जाएंगे that we get confused with the question. Okay? Do it, everybody. So I'm hoping the last question is done. To the next one. This is exactly the reverse now. I have to figure out what is the weight. Okay. One second. I'm just keeping the hint here. Meanwhile, everybody will keep solving. Sorry. Look, if all of you have arrived up to this point, check everyone. Have you able to do this? See, first figure out this 48.44.8 liters implies there are 2 moles of oxygen. So number of moles of oxygen is 44.8 liters divided by 22.4, which means 2 moles. So हमको 2 moles of oxygen given. And if you see the balanced equation, I think all of you must have got this balanced equation. Ethane reacting with 7/2 moles, giving 2 moles of carbon dioxide and 3 moles of water. Which implies, beta, that 7/2 moles of oxygen is essential for 1 mole of methane, right? Inka ratio dekho 7/2 and 1. And if I take 2 moles of it, so if I take 2 moles of O2, if we take 2 moles of O2 here, then how many moles of methane will be, how many moles of ethane will be used? So 7/2 moles के लिए 1 mole चाहिए, तो 2 moles के लिए कितना चाहिए? So 2 divided by 7/2, so 4/7. So we know the number of moles of ethane used. What can I write in terms of weight? So weight will be number of moles multiplied by molar mass. So 7/4 multiplied by molar mass of methane is 30. So we get 120/7 grams. Have you all got that? Right. So what about the volume of O2 here? Volume of O2, see, 7/2 moles requires 2 moles. Okay. And this is 44.8 liters, which means 2 moles, right? So you can see 7/2 moles of O2 is helping to form 2 moles of carbon dioxide. 2 moles of carbon dioxide. So 2 moles of O2 will help to form how many moles of carbon dioxide? So that will be 7/2, 2 into 2, 2 into 2 divided by 7/2. So which is 8/7 moles of carbon dioxide. 8/7 moles of carbon dioxide is formed. So volume of carbon dioxide will be 8/7 multiplied by 22.4 liters. So that's how you'll get the answer for carbon dioxide. Sure. See the solution, try to understand if there is any problem coming and tell me. Just give me a thumbs up, everybody. How many of you understood that? Two, three others. Krisha, is that clear, beta? Right. Aryan, how about you? Divya? Right. Good. Now, this is more about dealing number of moles, relating that to volume combustion. This is question, second type of question. Now, the third type of question you can expect from this chapter is based on concentrations. So now look at the concentration terms. Concentration terms. There are mainly 3 concentration terms you should focus on. First one is molarity, which implies number of moles of solute divided by volume of solution in liters, simply as a formula N/V. This is molarity. Next we have mole fraction, usually denoted by X, which is number of moles of solute divided by number of moles of solution. Got it? So if you have two molecules like number of moles of A and number of moles of B are given, then mole fraction of A will be number of moles of A by number of moles of A plus number of moles of B. So this way we will write mole fractions. Next, molality. Molality small m is written as number of moles of solute, number of moles of solute that divided by weight of solvent in kgs. So number of moles divided by W of solvent in kgs. These are very, very important formula, students. So make sure you are clear about these terms in understanding as well as relating all three of them. To relate all these three beta, we need few more terms like percentage weight by weight, percentage weight by volume, and percentage volume by volume. The most used is these two, percentage weight by weight and percentage weight by volume. Percentage weight by weight means weight of solute divided by weight of solution into 100. Similarly, if we talk about percentage weight by volume, it is weight of solute divided by volume of solution into 100. This is percentage weight by weight. Yeah. So I guess all of you understood that. Now, how do we relate these two terms with molarity? See, molarity capital M is percentage weight by weight into density into 10 divided by molecular weight of solute. This is first relation. Molarity is equal to percentage weight by volume into 10 divided by molecular weight of solute. This is the second relation. This is relating molarity and percentage weight by weight and molarity and percentage weight by volume. Next, relating molality. Molality is 1000 times of molarity by 1000 times of density minus molarity into molecular weight of solute. Please make sure everybody practice writing this because we tend to forget unless we write it. Okay, write it down, everyone. I hope all of you have written that. Finish, everyone. Now see, we will start discussing questions where first we will have a mixture of solutions and you need to calculate the molarity. This is a very typical question for KVPY. Like I have 100 ml of 0.2 molar HCl mixed with 400 ml of 0.2 molar HCl. Find the final concentration of HCl. So on mixing both of them, what will be the final concentration? For such cases, students, write this as M final is equal to M1 V1 plus M2 V2 divided by total volume V1 plus V2. Just use this, you will be able to figure out. Okay. This is about mixing cases. Clear? You will do that. You will finish that and tell me the answer. Okay. First, I'm giving you the types to help you. Second type of question is dilution, where we already have some concentration और उसमें हमने water डाल दिया. So if you add excess amount of water, the concentration of the solution decreases. So I have 500 ml of 0.1 molar H2SO4 is diluted to uh, diluted to diluted to 2 liters, by adding water, by adding H2. Find final concentration of H2SO4. So in such cases, we will be using M1 V1 is equal to M2 V2. Now in here, we are supposed to find out M2, which is equal to M1 V1 divided by V2. So learn these two things. In case of dilution, what should we do? In case of mixing, what we have to do? ठीक है, चलो करो अभी सब लोग. See the dilution case and see the mixing case and do the question in both of the cases.
Hello, sir. Please check the answer in the chat.
First one is 0.2. Next one is right. So in the first case, we have 100 into 0.2 plus 400 into 0.2 divided by 500, which is same 0.2 molar. So concentration does not change if you have the same molar of different volumes. Next one. Next question. So M1 is 0.1, V1 is 500, V2 is 2 liters. 2 liters means 2000. Correct. So I'm getting this as 0.1 into 5 divided by 20, which goes 4 times, which means this is 0.025 molar. This is the concentration of H2SO4. Clear? Simple calculations, everybody. Yeah, 25 as in 25 millimolar. So if we write it in molar, it will be 0.025. So I think all of you are able to relate that. Next formula based question you need to do is percentage weight by weight. Okay. Now I will not tell you the formula. You have to directly relate the formula and get the answer, students. Do that. 4% weight by weight of NaOH is present in water of density 1.2 gram per ml. Find the molarity of NaOH. Now you need to know which formula to be used and use it, get the answer. 2 to 3 minutes के अंदर आंसर देना चाहिए, उससे ऊपर जा रहा है मतलब you cannot solve it. Do it, everybody. Right, somebody got an answer. Let us see whether it is correct. So the formula you will be using is this. So molarity is equal to percentage weight by weight into density into 10 divided by molecular weight of solute, which is 4 into 1.2 into 10 divided by molar mass of NaOH, which is 40. So this will get cancelled. You will get this as 1.2 molar. Correct, beta. One Shraddha has made it right. Others, I hope you guys got that. Now, students, you should be aware of acids and bases. When do we say something are acids? When do we say something are bases? So just have a list of acids and bases first. List of acids. Here, HCl, HBr, HI. These three are very good acids. Then H2SO4, HNO3. These two are good acids. Then H3PO4, sorry, one more acid, HClO4. These three are good acids. And next we have H3PO4, H3PO2, H3PO3. These three are some good acids. Correct? Most of the time, our questions will be revolving around these acids only. Okay, most of the time. How come 40? 40 is the molar mass of NaOH beta. Shraddha, Na is 23. 23 plus 1, 24 plus 16, 40. Clear? So this is the list of acids. Next, what is list of bases? So when it comes to bases, we should have NaOH, KOH, RbOH, CSOH. This is one list. Then barium hydroxide, calcium hydroxide, magnesium hydroxide, strontium hydroxide. Got it? This is the second list. Next, aluminium hydroxide, FeOH thrice, ZnOH twice. These are all the list of bases. Acids supposed to give H plus, bases are supposed to give OH minus. Keep that much in mind. Acid base reaction will happen, H plus and OH minus will be consumed. Okay, which means if you look at an example of HCl treating with KOH, we will get this as KCl plus H2O. So basically we are reacting acid and a base to give salt and water. Done? So I guess this idea is clear to everybody, right?
Yes, sir. We'll zoom out the screen.
Now, the problem solving typically will be involved where you need to relate acid and base and how much amount of acid is left or how much amount of base is left. Okay, these are typical questions. I will start with one question. I will solve one question for you. Next question, you have to solve it. Have you all noted what are the list of acids and bases? Now look at this. 200 ml of 0.1 molar H2SO4 is treated with 300 ml of 0.1 molar NaOH. Find the nature of final solution. So what is the nature of final solution? Which means whether the final solution will be acidic, whether the final solution will be basic. Okay. You just have to go through that basic acid-base reaction and make a comment on the same. So first I'll show you how to do this. H2SO4 plus NaOH is an acid-base reaction. And here it would be forming Na2SO4 plus H2O. Balance it. You can see that there are two sodiums here. So which means I need to have 2 Na and hydrogen has to be balanced. So 2 here. So now you can see it is completely balanced acid-base reaction. Then mention the given amounts here. The given amount here will be 200 multiplied by 0.1, while here it is 300 multiplied by 0.1. 200 into 0.1 is 20 millimoles. This is 30 millimoles. Okay. Now students, check this out. For 1 mole of H2SO4, we require 2 moles of NaOH. So if I take for 20 millimoles, how much should I be expecting? So you can see 1 mole H2SO4 requires 2 moles NaOH. Then 20 moles implies how many moles? 40 moles. But how much have I gave? I gave only 30. The one which is less in quantity, that is called limiting reagent. So NaOH is the LR, limiting reagent. Okay. And students, limiting reagent will get completely consumed in the chemical reaction. So this won't be left anymore. ये completely consume हो जाएगा. But the other reactant which is left, that is called excess reagent, ER, excess reagent, ER. And this will be remained in the solution. This won't get completely consumed. Okay. Now, how do we do this? Check. 2 moles, 2 moles of NaOH, 2 moles of NaOH is using 1 mole of H2SO4 as per the balanced equation. Now, if I take 30 moles, millimoles, then how much do I require? So that is 30 divided by 2. So which means 50 millimoles are required. But how much did I actually have? 20 millimoles. Hence, number of moles of H2SO4 left will be equal to, we actually have 20 millimoles minus 15 millimoles, which makes it 5 millimoles. So 5 millimoles of H2SO4 is left. Okay. So you can say that we have H2SO4 left, which means the solution is acidic. Solution is acidic because acid is left. And if you were asked, find the concentration of H plus ions, H plus ion concentration is how much? If this is the question asked, then what you do? We have H2SO4, and H2SO4 is a good acid. It will dissociate as 2H plus SO4 2 minus. इस तरह से dissociate होता है. Which means if I have 5 millimoles which are left over, these 5 millimoles are actually in the form of 10 millimoles of H plus and 5 millimoles of SO4 2 minus. You know? So now the total number of H plus ions, are 10, and total volume of the solution is 200 plus 300. 200 plus 300, which is 500 ml. We know the number of H plus ions, we know the total volume. So we can calculate the concentration. So concentration of H plus is number of moles of H plus by volume total, which is 10 divided by 500. So that goes, so we will get this as 0.02 molar. This much is the new concentration of H plus. This is expected from you students. Now this is one of the good and slightly difficult questions, but it is, once you get a habit of learning this, it will become very easy. Anyone has any doubt here? Okay, how many of you understood? Just give me a thumbs up. Right. So follow that question and solve the next one. I'm writing it here. (400 ml of 0.01 molar HCl is treated with 200 ml of 0.02 molar calcium hydroxide. Find final concentration of H plus or OH minus ions left, and comment on nature of solution. Comment on nature of solution, whether it is acidic or basic. So do that.
Sir, please show the question.
Hmm? Previous question.
This sir.
Done, beta. Shall I scroll down?
Sir, okay.
Do this.
So this previous question solution not finished.
What, beta?
This previous question solution not written, sir. Just show.
Solution you didn't understand.
Sir, not right written, sir. Like the
Not written yet. It's okay. Don't worry about writing it. Please understand that question and try the next question. Everyone write the equation. See which is limiting reagent. Accordingly, check out whether H plus or OH minus, which is left over. See? I'm just putting out the hints. Those who are able to solve it, complete करो. जिसको बिल्कुल समझ में नहीं आ रहा है, फिर से यहाँ पे चेक करेंगे. So this is the respective acid-base reaction, and this is this balanced equation. Given is 400 into 0.01. Here 200 into 0.02. So this is 4 millimoles. This is also 4 millimoles. You can see 2 moles require 1 mole and 4 moles require 2 moles, but it is given 4 moles, which means this is excess reagent and this is limiting reagent. So HCl is limiting, and how much amount that is being used here? 1 mole require 2 moles. So 4 moles require only 2 moles. Sorry, 4 mole require 8 moles. So only 4 moles is given. So this is limiting. So you have to go with the opposite way, that 2 moles require 1 mole. So 4 mole require 2 moles, but given is 4 moles. So 2 moles will get consumed. So how much will be left over? 2 millimoles will be left over. So we will be left over with 2 millimoles. So hence it is a basic solution.
Sir, please repeat the last step.
2 moles require 1 mole and 4 moles require 4 by 2, 2 moles, but given is 4 moles. So 4 minus 2 moles makes it 2 moles remaining, right? 2 millimoles remaining. Therefore, what is the OH minus concentration? See, calcium hydroxide releases itself as calcium plus 2 OH minus. So 2 millimoles will get completely dissociated into 2 millimoles, and here it is 4 millimoles. Therefore, OH minus concentration will be equal to 4, which is the number of millimoles, that divided by total volume. Total volume is how much? 400 plus 200, which is 600. So it is 2 divided by 300. So which is 0.066 molar. That is the concentration of OH minus. So look at it. Anybody has a problem, let me know. How to decide basic or acidic beta? Shraddha, listen, whichever is the excess reagent, which means that nature will be left in the solution. So since base is the remaining amount, so the solution will be basic. If acid base, both of them are not left, then it is a neutral solution. So the understood? Has everybody got that? Now, students, the other day I discussed with you about periodic properties already. And during periodic properties, to learn redox reactions, one thing you must know is that what is the electronegative series? Like which elements have more electronegativity than the others? It has been found that fluorine is the most electronegative, then oxygen, nitrogen, which is almost close to that of chlorine, then bromine, right? Then iodine, which is almost same as that of sulfur, then phosphorus, which is almost same as that of carbon, then hydrogen, got it? Then we have metals. So I want all of you to remember this particular series. Electronegative series should be learned. Okay. What does this mean? That if fluorine is connected to any other element, fluorine will always take away electrons towards itself. For example, if we have H and F, electrons are here. So fluorine will drag the electrons towards itself. So it is almost like electrons are very close to fluorine. So this will have a partial negative charge and this will start showing partial positive charge. This is what I meant, electronegativity. Clear, students? So fluorine will be very strongly attracted towards attracting the electrons towards itself. Same way, if at all I say, let us talk about something like sulfur dioxide. Sulfur dioxide will have a structure like this. Don't worry about the structure yet, but see the nature. Between sulfur and oxygen, oxygen will drag the electrons towards it. And here also electrons will be dragged towards oxygen. So this will develop delta negative. This will develop delta negative. This will develop delta positive. Delta, this letter means delta. Delta means very small. Delta means very small. Okay. So small amount of negative charge, small amount of positive charge is created in these cases. Clear? So I hope all of you got a fair idea that what is electronegativity and how do we get these charges. Now students, given any compound, given any compound, you must be able to figure out something called oxidation state. Oxidation state. What does this mean? For instance, if you have oxygen connected to hydrogen and hydrogen, so this is how water is. But you know that by electronegativity, oxygen is more electronegative in nature. So oxygen will start pulling electrons towards itself. So electrons are pulled here, electrons are pulled here. So oxygen will have, gained delta negative charge. And students, this delta negative charge, I will call it as -2 just for the reference. It is not exactly -2, but hypothetically, I'm assigning it as -2. So this hydrogen will become +1 and this hydrogen will become +1. So these are not real charges. These are hypothetical charges. Hypothetical charges assigned. And how are we assigning that? Based on electronegativity. And these numbers are called oxidation states. Okay. So I hope all of you got an idea about what is oxidation state now. Yeah. Now, how do we calculate this oxidation state? It depends upon different rules of, oxidation states. What are the different rules of oxidation state? First, group 1 elements, which means that includes lithium, sodium, potassium, rubidium, cesium, all have +1 oxidation state in any compound, because they have very high tendency to lose electrons. They will always be lost 1 electron and attains +1 charge on that. Second, with group 2 elements, if you observe, which implies beryllium, magnesium, calcium, strontium, radium, barium, and radium. Barium, radium, all have +2 oxidation state, the same issue. Next, if it is about fluorine always have -1 oxidation state. Next one is hydrogen. Hydrogen is fair enough that if it is connected to metals, directly it is connected with metals, then it is -1 oxidation state. If H is with non-metals, then it is +1 oxidation state. So I hope all of you understood about first 4 important terms about rules of oxidation state. Now the 5th depends upon oxygen. Okay, connected to any other element, then fluorine usually shows -2 oxidation state. Like in the above case, if you see that for water, I told you that oxygen has -2 charge, which is hypothetical charge assigned. So that is because it is connected to 2 hydrogens, not fluorine. Okay. These are few rules of resonance. Now see few exceptions, especially comes in the case of oxygen. Suppose if at all I have H2O2, this is by structure, it is like this, H, O, O, and H. Observe this, students. Oxygen will gain 1 electron from hydrogen here, 1 electron from here. But दोनों ऑक्सीजन के बीच में तो कोई इलेक्ट्रोनेगेटिव डिफरेंस नहीं है, so there is no loss or there is no gain there. Hence, there is this oxygen has gained -1 electron. This oxygen has gained 1 electron. So both will have -1. So when oxygen is -1 charge, it is read as peroxide or peroxide. Okay, it is read as peroxide.
So,
Yes or no?
so you have wrote about the oxygen connected to the any other element, then it will
Fluorine.
be fluorine or oxygen there. Means I didn't understand.
If any oxygen is connected, if the oxygen is connected other than fluorine, like if you have oxygen and fluorine connected, then fluorine will take away electrons, correct? So oxygen will get positive oxidation state. Clear? But
Okay, sir.
other than fluorine, if you connect it with anything, it will usually go for -2. Understood?
Sir.
Now, suppose if you do not know individually how to calculate. So what we do here, we'll make a simple algebraic expression and solve it. How do we do that? See, H2O2 we have. Overall charge is 0. Nothing is mentioned means overall charge is 0. Hence, I can say there are 2 oxygens which are rated as X charge, plus there are 2 hydrogens, and each hydrogen will have +1 charge because hydrogen is connected to non-metal here. That is equal to 0. So X will be equal to -1. So that's how you will figure out using algebraic expression. Same way, this is one case where we say this as oxygen is read as peroxide, correct? That's why the name of this is hydrogen peroxide. Hydrogen peroxide. You all know what is the name of water? What is the name of water? Water is a common name, but how do we name it in IUPAC? Dihydrogen oxide. There are 2 hydrogens, so that's why we say dihydrogen and oxide. H2O2, dihydrogen peroxide. So sometimes even if you do not use di, it is understood that there has to have 2 hydrogens. So therefore it is hydrogen peroxide or dihydrogen peroxide. Both of them are right. Clear, students? Now suppose if at all I gave you one more example, KO2. And I know that potassium is always fixed charge. So therefore I have 2x plus potassium will always have +1 charge, overall equal to 0. So x is equal to -12. When the charge of oxygen is -12, we use the name superoxide. This is superoxide. Hence the name for KO2 is potassium superoxide. So it is potassium superoxide. Clear, students? So oxygen will have this differences in some cases, but otherwise, generally in all the cases, it is taken as -2. Now, why it helps, how it helps, look at it, students. Suppose if you have a molecule like KMnO4, the name is potassium permanganate, and I need to know what is the oxidation state of manganese. Friends, can you hear me now?
Yes, sir.
Yes, sir.
Sorry, I lost the connection. 1 minute. Yeah, can you all see me? Yeah. Now listen up. If we wanted to calculate what is the oxidation state of manganese, how do we do that? We know that oxygen is fixed, potassium is fixed, only manganese is not fixed. So what we do, we will take manganese as X, plus there are 4 oxygens, and as I told you, oxygen generally takes -2 charge, plus potassium always takes +1 charge, and overall charge is 0 here. So x minus 8 plus 1 equal to 0. So x is equal to plus 7. So the charge, the oxidation state on manganese is plus 7. Clear? Next, K2Cr2O7. Again, I don't know what is the charge on chromium, let's say. So there are two chromiums. I'll take one each chromium as X oxidation state. Plus, there are 7 oxygens. Every oxygen is minus 2. Plus, there are 2 oxygens. Every oxygen, 2 potassiums. Every potassium is plus 1. Overall equal to 0. So 2x minus 14 plus 2 equal to 0. So 2x is equal to 12 and x is equal to 6. So this is the oxidation state of chromium in this case. Okay. That's how we need to figure out what is the oxidation state of manganese, chromium, or any other substance given. Next, I'll take few examples quickly so that you start getting an idea कि कैसे solve करना चाहिए. CO3 2 minus. Imagine carbon is not given. So X plus 3 moles. Every oxygen is minus 2. Overall charge is minus 2. So we have X minus 6 is equal to minus 2. So X is equal to plus 4. So X is equal to plus 4 is the charge on carbon here. Okay. So I hope all of you got an idea how to get the oxidation states. The major part of this chapter, redox, is about finding out oxidation states, everybody. Yeah. So just make a note of it. Write down from here.
So just 1 second, show the down slide. Just 1 second.
Yeah, tell me. Any doubt here?
No, sir, just send.
Then
Show the.
start from here. Redox reactions, electronegative series, what is oxidation state, how to apply the rules of oxidation states.
Sir, last slide for 1 minute.
Last slide.
Yes, sir.
1 minute. Let me check if everybody has got this.
Sir, I am asking the one before this.
Yeah.
Yes, sir. Yes, sir.
Done, everybody? KMNO4, K2Cr2O7, CrO3, any compound now you have been given, you should be able to figure out what is the oxidation state. Okay. So I'm giving you a few questions, do them quickly. We have 5 minutes, so we'll finish at least 5-6 of them. H2SO4, find the oxidation state of sulfur. H3PO4, find it for potassium. Next, barium, Ba nitrate, NO3 twice, find it for nitrogen. Barium nitrate. Next, calcium sulfite, calculate it for sulfur. Do this for everybody. Just like the way I have did the above 3, I want all of you to do the oxidation state for the next 4. First one, X is 0. No, Shraddha, check properly. See, this is X. There are 4 oxygens. Each oxygen will have -2 charge. Plus there are 2 hydrogens. And each hydrogens will have +1 charge. Overall equal to 0. So X is equal to +6. Okay, beta. Right, Anu. Correct. Second one, phosphorus, X, plus there are 3 hydrogens, +1 charge, plus there are 4 oxygens, -2 charge. Overall is equal to 0. So X is +5. Right? Nitrogen. Nitrogen here is X. X plus 3 oxygens, -2 charge. And this is 2 times. Plus there is barium. Barium is +2. Barium is +2 only. Overall equal to 0. So X -6 is equal to, correct, this 2 goes to the other side, so I'll get this as -1. So -1. So X is equal to +5. This is the charge on nitrogen. Correct, Shraddha. So sulfur is X plus 3 oxygens -2, 1 calcium +2, 0. So X is equal to +4. So that is the charge on sulfide. Got it? Yes, Anu, correct. So this is how you will figure out the oxidation state of each and every element. Okay. So let me write few more here. Write down about that. NH4 plus, do it for nitrogen. Find it for nitrogen. Na2S2O3. Find it for sulfur. NaNO2. Do it for nitrogen. Next. FeSO4. Do it for iron. Got it. AlNO3 twice. Do it for aluminum. First one, correct, Shraddha. Very good, beta. Go for the next one. Others, figure out, give me the answer. Right, Mandar, correct. श्रद्धा श्रुति second one फिर से रीचेक करो बेटा. Next one is fine. Shraddha, this x is minus 20 is for which one, beta? Now look at this. This is a usual surprise. Now, nitrogen, we will have x plus 4 hydrogens plus 1, overall equal to plus 1. So x will be equal to minus 3. तो ये तो easy है. Second वाला भी easy है. There are 2x plus 3 oxygens minus 2 plus 2 because sodium हमेशा plus 1 रहेगा. So equal to 0. So x is equal to 6 minus 2, 4 divided by 2 is 2. So x is equal to 2. Next, third one is also easy, that x plus 2 oxygens and 2 oxygens will be minus 2 and this is plus 2 equal to 0. So x is equal to plus 2. So this is about for nitrogen. Now when it comes to last two cases, students, sulfate, nitrate, right? Here you should know the opposite way, right? Everyone, can you hear me? Yeah. What you need to do, now you must know this way. SO4 will always carry minus 2. SO3 will always carry minus 2. Okay. NO3 will carry minus 1. NO2 will always carry minus 1. Only chlorine will carry minus 1. Bromine will carry minus 1. Iodine will carry minus 1. Fluorine will carry minus 1. OH will carry minus 1. Cyanide will carry minus 1. Got it? Now these are the typical ions we will keep coming across. So इनके direct charges पता होने चाहिए, surface charges -2, -1, -2, -1, -1 and all of this. If you know that, it becomes more easier now. See, iron is X here plus sulfate. Overall SO4 is how much? -2. So I simply write -2 equal to 0. So X is equal to 2. So that is the charge on iron. Clear? Next for aluminium. Aluminium, if you take this as
Excuse
X,
me, sir. NaNO2 it will be plus 3, na?
NaNO2 plus 3, sorry यहाँ पे 2 लिख दिया मैंने, plus 3. Yeah, thank you. So here you can see x plus 2 times of -1 equal to 0, so which makes x is equal to 2. Correct? So x is equal to, यहाँ पे 3 times है ना, it should have been 3 बेटा, मैंने 2 लिख दिया, 2 exist नहीं करते. So aluminium NO3 thrice, so x will be equal to 3. Clear? So make sure you remember these terms, beta, that surface charges for these ions will be how much? Okay, -2 or -1 and so on. Clear? So that is about oxidation states. Sir, we have a doubt. Why do we consider N1 is equal to 2 for emission spectrum of helium plus? N1 is equal to 2. No, we are not considering. We are considering N1 is equal to 2 only if it is a Balmer series. Okay, beta. Shraddha, is that clear? Yeah.
Done, sir.
Okay, guys. So I'll close the session here now.
Sir, I have one question in the
Yes.
video lecture of problems.
Yes.
Sir, fifth question. When 262 gram of xenon reacted completed with 152 gram of fluorine, a mixture of ZDF2 and ZDF6 was produced.
Xenon question. You see xenon question. Yeah, this one. Okay.
Sir.
Tell me.
Sir, see, here a mixture of ZDF6 was produced, and sir, you have wrote that the value of ZDF and ZDF6 we have to find the
Okay,
number.
X6 was produced. Okay, okay. Right. So
So
if this is F6, then the ratio might change. Let me check. So we have F6 here. So here, how many moles we will have to have? We'll need to have 4 moles here, right? Clear? So 2 moles requires 4 moles, right? Correct. So, and the same 4 moles are given to us. So the ratio will still remain 1:1. Okay.
okay, sir.
Okay.
Sir, एक minute note करता हूँ.
Mhm.
लगे हुए हैं यहाँ
Done? Right. Okay, Shraddha, I'll post that lecture also. I have not seen whether that lecture was posted or not. I'll check this out and post it again. Okay. Thank you, guys. Chalo, I'll see you in the next session.
Bye, sir. Thank
Bye.
you, sir.
Thank you, sir.
Okay, beta.